Dr. Howard, we can't hear you.
Can you hear me now?
Yes, sir. Thank you.
I don't know what happened. Oh, I know what happened. Yeah. I clicked the power button off when I tried to put it on my belt. Well, you know what? I'll just stick it in here. And I won't turn the power off. All right, that should do it. All right, so it's easy to compare biomes by looking at plant communities because plants are obvious. You can tell that this is a rainforest. You can tell that that's a savanna. You can tell that that's a desert and that that's a tundra. So we distinguish 9 general categories of biomes or types of habitats. And now, there we go. What's interesting is that although they are different habitats on different continents, perhaps, we categorize them as biomes, that is a type of habitat, because they impose similar kinds of selective pressures on the organisms that live in them. So, desert habitats impose water limitation on everybody who lives there, regardless of whether it's an Asian desert, an African desert, or an American desert. As a result, we see convergence in organisms that live in deserts, regardless of where they are on Earth. So what you see here is 2 different deserts and 2 different plant families that are completely unrelated that have adapted to the conditions in these deserts. This is a cactus in Arizona, and this is a euphorbia in an African desert. So this is related to roses. This is related to tropical milky sap poisonous plants. Completely different, but they look similar because they share similar adaptations to the environment. Okay, and that's why we're going through this the way we are, setting the stage for what's the environment, or how does the environment get produced, and then what's the environment conditions, and then we can talk about the adaptations to those environments. So here is how we think of these biomes. Now, it's not like they have sharp boundaries. They grade into one another, but they're basically determined by the combination of temperature and precipitation. So if you think about it, you have a column here on the right-hand side that's very wet, or very warm rather. And here's warm and wet, that's tropical rainforest. For those of you at home, we are looking right here and then moving down. And then as it gets drier, but it's still warm, then you have what we call seasonal forest or savanna. And then finally, you have hot deserts where it's dry and warm. And this is the average annual temperature. So this is day and night combined. And 30 degrees centigrade is 86 Fahrenheit. So that would be the average temperature all year long, day and night. That's pretty warm. There's a second column here that's regarded as temperate. So at the top, you have a temperate rainforest biome where it's moderately, we call that mesic. It's not hot, it's not cold, it's temperate, and it's moist. And then if it's a little drier, you have temperate seasonal forest, like our forests here in Louisiana. If it's a little drier in that same column, then you have either woodland or shrubland. And if it's really dry, then you tend to have the temperate prairies, or sometimes cold deserts or cool deserts like the Great Basin Desert. And then finally, you have this cold area here that includes Boreal Forest right there and tundra. And notice that in some cases, the average annual temperature in boreal forest or tundra is below zero, below freezing, the average temperature. Means there's a very long cold season, very short warm season. Okay. Notice also that there are no biomes in the top left triangle here. That's because this is cold air. What do we know about cold air? It doesn't have a lot of water containing capacity. So it is not physically possible to have a combination of very cold and very wet conditions. Physics prevents that. So we're going to walk through these 9 biomes, tell you a little bit about them, and explain where you find them. So here's a general map, sort of mapping out these biomes. And if you'll recall, when we were talking about the setup of the major air circulation patterns on Earth, it kind of sounded like there should be bands of these habitats, you know, warm and wet, maybe slightly cooler and drier, maybe deserts then as you go away from the equator. And it should be kind of a continuous band. But then on Friday, we talked about the reasons why that wouldn't be so simple. We looked at the regional influences on climate, right? So this is what it actually looks like. So here along the equator, you see swaths of this dark green, that's tropical rainforest. Just to the north and south, you see this lighter green, and most of Africa, south of the Sahara, is this lighter green. And that is tropical seasonal forest, or savanna. For those of you at home, we're looking at this. And then you see the desert belts, and they're really obvious here in Africa and out here in Australia. There is a strip here, which is interesting and might require a little explanation. And we have some up here, but notice at the same latitude further east in North America, really Louisiana and Florida are at the same latitude as the North American deserts, and yet they are not deserts. That's the regional influence of being close to the Atlantic Ocean and the Caribbean. The North American deserts are in the center of the continent, and they do not get as much rainfall as we do because they're further away, so desert conditions prevail. So you also have some grasslands, and they occupy large areas in Central Asia and Central North America. And then above that, well, depending on kind of where you are, you have this brownish thing. This is the great deciduous forest of North America here in the east, from Florida all the way up to Nova Scotia. In Europe, it extends all the way from Britain well into Central Asia. And then you have another big patch of temperate forest out here in East Asia, including much of China and Japan and Korea. Then above that, you have the remaining 2. You have the Taiga, the great boreal forest of conifers, and you have a lot of tundra here. And notice that we haven't done much of anything with Antarctica. Okay, we missed one because it's really tiny, and that's the Mediterranean. So you have a very special climate here in the southern cone of South America and South Africa, and it's kind of this orangey thing. And then you have the Mediterranean itself, and that's where it takes its name because it was first described there. It's a Mediterranean biome. You have a little bit in South Australia, Southwest Australia, and a little bit on the west coast of North America. Okay. There is one more that's hidden, and that's temperate rainforest. And that's basically this little light green strip here, just above California into British Columbia. And there should be, well, I don't see that they've got it down there. Oh, well, here you go. Here's New Zealand. New Zealand is also temperate rainforest. So it's more complicated than you might expect based simply on global air circulation patterns. That's because of the regional influences on climate. Now, in order to understand these biomes, we frequently use climate diagrams. And what we do with climate diagrams is graph temperature and precipitation on a single graph. And this is an example of what a climate diagram might look like. Down here on the left, you see that the red line is temperature and the blue line is precipitation. And you see for this biome, the blue line is always above the red line. Now, how are we making any kind of equivalence between precipitation and temperature? Are these randomly on there? No, they are not. They actually are directly equivalent. And that is because we've done experiments where we've looked at the evaporation out of pans of water placed outside in different biomes around the world. And we've discovered that there is a relationship between mean temperature and the mean demand for water evaporation. And that is, if you look at the axis, you can clearly see it. For every 10 degrees of increase in temperature, you increase the demand for moisture by 20 millimeters. So if you have a biome that has a mean July temperature of 10 degrees centigrade, the plants that live in that biome must have access to at least 20 millimeters of precipitation in order not to wilt and die. So if the blue line for precipitation is above the red line, it means there's water excess and plants can survive. If that blue line dips below the red line, as it does on the bottom right here, you can see that this is drought. Okay, there is not enough water available for plants to photosynthesize, and they may have to shut down. This is a really interesting Mediterranean climate, which we'll talk about shortly. But anytime the precipitation line falls below this temperature line, that's a real thing. That's not arbitrary. That shows you that the demand for moisture exceeds the available moisture, and plants must have drought adaptations. On the other hand, if the precipitation line remains above the demand line, means there's plenty of moisture to go around. And the higher up that precipitation line is, the more excess water there is for plants to work. Okay, so that's a really critical thing for trying to help us understand why these biomes differ in the ways that they do. So let's look at those 9 terrestrial biomes. We'll go through them one at a time. We'll start with the column on the right, the tropical column, the warm habitats here, tropical rainforest, seasonal forest, and savanna and deserts. And first we'll look at tropical rainforest. Okay, tropical rainforests have at least 2,000 millimeters of rainfall annually, and it's generally evenly spread across the, the year. You'll remember that close to the equator, you get the intertropical convergence zone dragged across you twice in a year. That means that there's no really dry period if you're really close to the equator, because you're getting rainfall all year long. Okay. This is typically an area where you have large trees, maybe 40 meters tall, and closed canopy, very, very rich and diverse. And that is because of the availability of moisture. There's plenty of moisture around for plants. On the right in the middle, you see a map of the distribution of tropical rainforest. About half of it is in Central and South America. About 20% is in Africa, and about a third is in these scattered patches in Indonesia and South Asia. Okay. This is the area that has the highest species diversity of any group of organisms anywhere on Earth. Okay. This is not necessarily an easy place to live, though, because the high temperatures and rich rainfall mean that microbial decomposition of organic matter proceeds very fast. So plants that live in this zone are actually where all the nutrients are. There can be very little soil fertility in tropical areas simply because of the high rainfall. Anything that dies and falls to the forest floor is rapidly decomposed, and because of the high rainfall, the inorganic ions that are produced run off into the rivers. So soils are not particularly suitable for agriculture. Now we have a crisis of biodiversity because rainforests are being converted to agriculture, and this is kind of a futile pursuit. You cannot maintain any kind of agriculture in the kind that you would have in the temperate zone in these tropical habitats. There simply aren't the nutrients in the soil. So you cut down rainforests, you have maybe 3 to 5 years of profit, and then that's it. You have to move on. Also, rainforests are really, really, really favorable because of their year-round warm and moist conditions. They're really favorable for pests and for diseases. So tropical rainforests are not places where people want to live. And the reason we're having a biodiversity crisis now in tropical rainforests is because we've used everything else. This is the last place. It's the last marginal habitat. So here are some climate diagrams that give you examples of tropical rainforest climates. You see that in every case, the annual rainfall pattern exceeds the demand by quite a lot. And you'll notice, if you look closely, that the axis goes 20, 40, 60, 80, 100, and then 300. So it's jumping. This is not a linear axis here. Okay, now remember that as you go north and south of the equator, you start to get a single rainy season a year and a dry season. And if you are in that belt, there's not enough moisture to sustain a year-round rainforest. Instead, you have seasonal forests. They leaf out in the wet season, they drop their leaves in the dry season. Okay. Savannas have longer dry periods than seasonal forests do. So whether you have a savanna or a seasonal forest simply depends on the relative length of the dry season in that habitat. There are two other things that may influence whether you have savanna or forest. One of them is fire. Frequent fires favor savanna. However, there's another thing that goes on, which we'll see in the next slide. Now, the thing about savannas is that because there's a dry season, it's like the winter in temperate zones. You kill the parasites and diseases, and you kill the pests. This is much more favorable to agriculture. So people who live in the tropics have tended to settle in seasonal climates rather than tropical rainforest. Okay. You still have lots of rainfall that's bleeding nutrients out of the soil, but you don't have quite the same rapid nutrient loss that you do in rainforest. So here are some tropical seasonal habitats. And here's Acapulco, Bombay, and Darwin. Notice that they all share the same pattern. Now, on the right here, Darwin, Australia is in the southern hemisphere. So if you look at the months here, you can see that they start with July because that's their winter. And over here on the center and the left, you have Acapulco and Bombay that are in the northern hemisphere. Their year starts with June. We simply do this so that we can have a comparison that's easy to make, right? Now, in each case, you have an extended dry period where the moisture available, it falls far below the moisture demand. So you can't have a year-round tropical rainforest. You must have either a seasonal forest or a savanna. Okay, and you may ask, what's the shading, the red shading down here on these 12 months of the year? That's the growing season. That's the number of months where temperature is above zero and plants can grow. It's not important in tropical habitats because it's always that way, but when we get to temperate and cold habitats, it will be. So be sure to pay attention. So these are forests. Notice that you have 1,400 millimeters of rain, 1,800, 1,500, and you've got a number of months of really high rainfall. Let's look at savannas. And you'll see that over here in the middle and on the left, on the right rather, you have tropical habitats that have much longer dry seasons. They're too long to support trees. There just isn't enough rain for something big like a tree to persist. So these are savannas. Okay. On the left, you see something that should be a forest, but is in fact a savanna. This is Venezuela. And you see that it's got plenty of rainfall. It's got a shorter dry season. Why is it a savanna rather than a forest? Because there's an impermeable layer in the soil that prevents drainage. So basically you have a flooded forest. Basically you have a seasonal marsh. Trees don't do well when their roots are flooded. Grasses have very superficial roots, and so this is a savanna not because of the length of the dry season, but because the trees can't respire. Only the grasses persist. So things that determine whether you are a forest or a savanna include soil moisture. Too wet, you're a savanna. Fire, frequent fires, you're a savanna. And the length of the dry season. Long dry season, you're a savanna. Okay, then let's move on to the deserts. Here are your subtropical deserts. And you see that most of this is in North Africa and Australia. This is the belt around 30 degrees north and south of the equator, where the falling air masses dry out the soil. Okay. You also have some kind of peculiar looking situations here where you only have desert on the west coast of South America and Africa. And over here, you have deserts kind of shifted to the west in North America also. We'll talk about why that is. Now, in deserts, there's very little organic matter because there's very little plant growth. So these are very unsuited for most human activities. You can have some surprisingly rich biodiversity in deserts. The Sonoran Desert in Arizona, primarily in North America, gets rainfall twice a year, half the year from the Pacific, half the year from the Caribbean. Summer storms come from the Caribbean, winter storms come from the Pacific. So even though it's not a lot of rainfall, it's more than some other deserts. And so you can get rich plant communities that contain many kinds of cacti. Yes. Okay, so the question is, are rain shadows related to the distributions of some of these deserts? That's exactly right. That is why you see the deserts, particularly in South Africa and South America, located on the west coast of those continents. Where's the rainfall coming from mostly? It's mostly moving from east to west at that latitude. That means that in Africa, it has to pass over the South African mountains where most of the moisture is lost. And then by the time it gets to the west coast of Africa, now a rain shadowed desert. The same is true here in South America because, of course, if moisture is coming from east to west across South America, it has to pass over what? The Andes. And so by the time it falls down the Pacific side of the Andes, it is extremely dry and you have a rain shadowed desert. In North America, you also have rain shadowed deserts because you have mountain ranges that surround most of this area here in the Sonoran Desert. That is this area right here, for those of you here. They bleed out a lot of rainfall in the summertime from the Caribbean, and they bleed out a lot of rainfall in the wintertime from. So yes, good catch. Okay, so here are a few desert climate diagrams, and you see that in every case, for most of the year, the demand for moisture exceeds the supply of moisture. And that's true in Yuma, Arizona, here on the left, and in Chad in the center. It's not quite so true here in Mongolia, but there's some special things going on in Mongolia, because look at the growing season in Mongolia. It lasts from May through September, and then it freezes and the plants can't grow. When is the time period where demand exceeds supply? It is exactly during the growing season. So when it's warm enough for plants to grow, here on the right, there's no water for them. When it's too cold for them to grow, there is available moisture, but they can't use it because it's below 0. Yes. Okay. So the question is, if we know something about what generates deserts, is it possible to reverse that process? And the answer is yes. Now, it's hard because you are at the mercy of large scale weather patterns. But as you will see later in the course, local rainfall is mostly derived from local plant growth. So if you were to plant a green border on the southern edge of the Sahel in Africa, at the southern edge of the Sahara Desert, you would increase the rainfall. So even though it is a dry area, we can manipulate these things. And that is exactly what's happening in Niger right now. There's a huge project to plant gardens at the edge of the Sahel. And the theory is that that will eventually increase rainfall. It's not going to turn the Sahara into something other than a desert, but it will make the borders of the desert much more livable, much greener. Okay, this is why we sometimes don't get through all 9 of these terrestrial biomes. Now we're going to move to the temperate biomes, so temperate rainforest, seasonal forest, woodlands, or Mediterranean climates, as we call them, and grasslands and cold deserts. So temperate rainforests are probably the ones that you know least about, and that's because they are small and scattered. They have mild temperatures, they have a long growing season, and they are extremely wet. But they're temperate. They're not tropical. So they occur only in very limited areas. New Zealand, the North Pacific coast of North America. If you go to Olympic National Park in Washington State, you are in a temperate rainforest. Okay. You have temperate rainforests only because of the proximity to the ocean. That's where the moisture is coming from. The other thing about them is that they're not particularly species diverse. They're temperate forests, and they don't have a very high biodiversity. They have an amazing amount of production, but it's relatively few species doing it. Okay, so here on the map in the center on the right, you can see that you've got a little patch here. You've got patches down here in New Zealand and the south coast of East Australia. And you've got the Chilean rainforest, which is a pretty amazing place. So here's a typical climate diagram of British Columbia. And you can see that, yeah, there's a cold season in January through March and again in December. But the available moisture exceeds the demand all year round by a lot. Okay, now mostly what we have is temperate seasonal forests at this latitude. Okay, so if it's moist enough to support trees, they're temperate seasonal forests that drop their leaves during the winter. Okay, and here's a typical climate diagram on the bottom right here, and it shows you that there is some period of time where the average temperature is below zero. It is winter. However, the supply of moisture exceeds the demand by a fair amount all year long. So this is our forest here in Louisiana. And they're trying to give you some general guidelines about what plants are there. They're really diverse. Don't take it too seriously that they're saying they're dominated by things like maple, beech, and oak. It's deciduous trees. They're just examples of deciduous trees. Okay. Now, you can get some kinds of forests that are very near the ocean, as in right on the east coast of North America and right in Britain and northern France and in Japan. And you can get these deciduous forests that are further away from the ocean. And as they get further away from the ocean, of course, the climate's going to change and you'll get some different kinds of plants. In fact, if you get too far from the ocean, or if you have a period of drought, instead of deciduous trees, you'll get conifers, which are more drought resistant than deciduous trees. So we'll have a look here at some of the temperate forests that are typical here. So you got two broadleaf deciduous forests where you have broadleaf trees that shed their leaves in the winter, and that's here in the center in Philadelphia, and here on the right in France. And this is a typical pattern where the demand for moisture is never as high as the available moisture. However, we do have one example of how you get conifers in these temperate seasonal forests, and that's over here on the left in the Andrews Forest in Oregon. And what have you got right in the middle of the growing season? You have a brief period of drought. That is too stressful for broadleaf trees, which need a lot of water to evaporate through their leaf surfaces. In cases like this, conifers have an advantage because they're more drought resistant. They don't need as much water. If you have sandy soils, as we do in much of the South, again, moisture percolates through and is lost, and it stresses broadleaf trees. So in much of the South, the temperate seasonal forest is dominated by pines rather than broadleaf trees. So soil conditions and drought conditions can turn these temperate forests from broadleaves to conifers. Okay, what this slide is calling woodland or shrubland is what I call a Mediterranean climate. It's a very special kind of biome in which there is a all year round growing season, but you have a summer drought. Okay. Now, the summer drought puts stress on plants and they must have drought adaptations. This is typical of places like Southern California, where you have those brush fires sometimes. Australia, where you had those terrible fires. those are drought adapted plants. In fact, they are so drought adapted, they require the soil to be burned for them to germinate. So it's part of their life cycle. They expect drought. They have oil-rich leaves that promote fires during these droughts. And it's a suite of adaptations that is very consistent wherever you find Mediterranean biomes. The wildfires in Greece that are currently going on, that's Mediterranean biomes. There's a summer drought, and the vegetation needs to be burned to germinate, for their seeds to germinate. Okay. The summers are dry here. So these are drought adapted plants. And this is a typical scene in, I think this is California, but then here's some examples, and you can see that the summer drought period varies quite a lot. Sometimes it's really, really long, like here in San Diego on the left, it lasts from approximately mid-May to December. And in California, the rain comes in October and November. And it's dry all summer long. I grew up in California. I did not know there was such a thing as summer rain until I left. But Italy is another great example of a Mediterranean climate, and Adelaide, Australia, here in South Australia again. Okay, finally, grasslands versus cold deserts. Not all deserts are hot. You'll remember that tundra is a cold desert. The Arctic is a cold desert. So depending on the amount of rainfall, you may have enough rain to support grasses, but not trees. So you have a savanna or a grassland, a temperate savanna or grassland. Or if the dry period lasts too long, you can have a cold desert. So here you have typical grassland at the top right in the western United States. This is in South Dakota, and you see bison grazing there. And in the center, you have the map that shows you the great grasslands of Central North America and Central Asia. It's not nearly as common anywhere else on Earth, but there is a little belt in South America here. So there's a gradient then. If you have a lot of rainfall, but not quite enough for trees, you'll get something that we call tall grass prairie, where the grasses grow above your head. If it's a little drier, you'll have medium prairies where it's about waist high. And then you have short grass prairies where it's maybe knee high if it's quite dry. Any drier than that, and you shift over into cold deserts like Nevada. Okay, so here's some examples here. You can see that for the grassland areas, you do have moisture exceeding demand most of the year, not always, but mostly. But the amount by which it exceeds demand is not as great as it would be if you could support a forest. Okay, finally, we'll look at boreal forest and tundra, and I think we may actually get through this. Okay, so boreal forests are the great coniferous forests of Canada and Siberia. They have an enormous amount of carbon storage up there. And they are virtually all conifers. And that is because conifers are drought resistant. Now, it's a funny kind of thing that we're talking about here because it's not like there's an actual drought. This is an area where air masses are rising and causing rainfall. And so you'd think, well, there should be a lot of water there. Well, there is, but the problem is that it's not always available. You have a long cold season. And of course, plants can't use water during cold season because they are dormant. So there's actually seasonal drought. There's one other thing that causes trees to be stressed in these environments, and that's the low temperatures. If you have a lot of rainfall and you have low temperatures, is the rainfall going to evaporate? No, it's going to sit on the landscape, pond up and form saturated soils. And what did we say about saturated soils in the tropics? Trees don't like them. Broadleaf trees can't respire in these saturated soils, but conifers are better able to do that. So this is why conifers dominate these habitats. Okay, and so here's some taiga climate diagrams, and you see now you have a short growing season, maybe only 4 months in some cases, or even 3 months here on the right-hand side where you have a Russian taiga forest, and the growing season is basically 3 months, July through August, June through August rather. And it can be quite cold. You can see over here on the right that the minimum temperature, average temperature in January is about -45 centigrade. That's pretty cool. That will freeze diesel fuel in your fuel line. And there's only a very brief growing season. And notice this is really obvious in the diagrams on the left and on the right, that during the growing season, the amount by which moisture supply exceeds demand is very small. That's borderline drought. That gives conifers an advantage. So conifers are going to have advantages in these kinds of climates. Okay, finally, there's tundra. Okay, and this is very cold and very dry. Okay, you cannot support large plants here simply because there's not enough primary production. There's not enough water to support that primary production. And you can have permanently frozen soils called permafrost. That is what we see in the northern reaches of Canada and Siberia. It's also what we see at the tops of mountain ranges like here in Central Asia and here in the Andes and to some extent in the North American, Canadian ranges. Very dry and very cold simultaneously. Plants cannot grow tall because if they do, they get frozen off during the long winters. On the other hand, if they grow low to the ground, there's a blanket of snow that insulates them from the coldest temperatures. That's why you have the growth forms that you do in tundra. So here are a couple of examples of tundra climates. And you see that although you may be close to the ocean here in the center diagram, so you don't have really cold minimum temperatures, you have a very short growing season, again, just like the boreal forest. And it's drier. The total precipitation is less for these tundra habitats. Okay, and you can have extremely cold conditions. These are not as cold as the coldest taiga because they're closer to the ocean. So there's a little bit of moderation of this climate simply from the fact that they're near the Arctic Ocean. As cold as that may be, it's not as cold as it is further inland. Okay, so we just raced through these 9 biomes. We got it done. And I will see you Wednesday, and we will talk about the equivalent aquatic habitats, which we often do not call biomes. We simply call them aquatic habitats. Okay. Guys, we will see you Wednesday. Hopefully, I'll see you, some of you here. And I'm going to end this for you.